In this lesson, we talk about using dependency injection. The objectives for this lesson are to find out what is dependency injection and why use dependency injection. We'll talk about how the service container works in ASP.NET, talk about service lifetimes, and then we're going to see several demonstrations of dependency injection. ASP.NET creates what's called a services container, and this is just a structure used to hold instances of services or names of services to be injected. We register our classes into this service container for the ones that we want to have injected through this dependency injection mechanism. So .NET creates these instances of these objects that you've registered for you and inserts those into classes through constructors or even the methods. This is called an inversion of control design pattern, wherein controllers don't create the objects that they need to perform their work, and this is a good separation of concerns. So the way this works, let's say we have a service container structure, and it's got a logger in it and a configuration manager type class in there and a data class and a security class and a diagnostics class. What happens is if a controller in their constructor or in one of their action methods has the same name of a class that's in the service container, when that controller gets created by ASP.NET, through dependency injection, it goes out to the service container and grabs an instance. Same thing if we had another controller and it has maybe the logger and the security and the diagnostics or the data that match up to this service container, dependency injection will take care of putting all of them into that controller. This is really neat because think about it. We're not creating the controllers, right? ASP.NET is based on the requests coming in. So if we don't have any control over how they're being created, it has to have some way to inject these service dependencies. And it's done through this mechanism called dependency injection. So why do we do this? Well, I kind of just mentioned one fact, and that is that we don't create the objects. This really is better for code reusability. It makes our applications easier to test and maintain. A big one here is it reduces coupling between classes, because typically what we're going to do is we're going to insert an interface into each of those. So instead of logger, it'd be iLogger. Instead of configuration, it'd be the iConfiguration. So we don't really know what type of thing we're getting in. Also, we're reusing objects that are already created. This reduces instantiation time. And like I just mentioned, it allows us to inject different objects. So the configuration, we may have an iConfiguration. We may have several concrete instances. One that gets the data from a JSON file. One that gets the data maybe from a database table or an XML file. Our classes don't know the specific concrete instance we're going to pass to them. All they know is they get a configuration object that gets the data from somewhere. Same thing, maybe you have that data service that I talked about, right? So a database, we may get the data from tables, maybe get it from cloud storage, from memory, from XML files, from JSON files. Again, the controller doesn't know and doesn't care the specific concrete instance. That's taken care of when we register our classes through the dependency injection service up front. And then after that, it's all injected and our classes don't worry about it. The classes put into our dependency injection have a specific lifetime or lifetimes that they could be registered as. The first one is called a singleton. Now that means that these instances of objects that are placed into the service container are created the first time they are requested, and then after that, no other instances are created. So regardless of this one type of class gets passed to 10 different controllers, it's always the same instance. We typically use singletons for things like configuration settings, database objects, things that don't really change that much. The other type of lifetime we have is called scoped, and scoped means it's created once per client request. So it's always the same, even if one controller calls another one, it would pass that same request through, and then it's destroyed at the end of the request. So we use this for data that needs to stay around regardless of how many controllers the calls go through. So if controller 1 says, well, I'm going to redirect you over to controller 2 over here, this one instance of this object is going to pass through that. Another service lifetime we have is what's called transient. Now this is created each time they are requested. So if we have controller 1 that redirects over to controller 2, it's going to be different instances of that particular object. So it will be created brand new for each individual call, and then it's destroyed when that block is finished. The controller, the action method, whatever it has been calling this thing. Now, I'm going to tell you these aren't used too much. We really only use them when the data really needs to be different between the different controllers or the action methods or the services or whatever. To illustrate this, we're going to create a settings class that we're going to put some settings into, and we'll talk about how it can be injected using dependency injection. Right mouse click on the entity layer folder and add a class, and this one's going to be called ADVWorks API Defaults. Go ahead and add that class. And what we're going to put in here are a few properties. We're going to have a public date time created, a public int product category ID, a public int product model ID. And in the constructor, we initialize all three of those values. Created, we really don't need that, but we're doing it just so I can show you the date time that each of these instances of the object are created. Now, what we need to do to register this with DI is we go over to our program.cs, and right below here where I have the add and configure services, I'm going to do a builder.services.addScoped. Generally pass an interface and then the actual concrete instance. In this case, we only have the class, and that's fine for configuration settings. A little later on, I'll show you how to do it interface, don't worry. But this now adds a scoped version of this, which means for every call, it's going to get a new instance. And we can prove that out by creating, under our controllers folder here, a new class. I'll just create a class here called Settings Controller. And into this, I'm going to create this controller. And it has a private read-only version of that AdventureWorks API defaults, and I've called it _settings. In the constructor, we inject that. Okay, now, so dependency injection is going to look in the services that we just registered with program.cs, and it's going to look in there and say, do we have an instance of this? It'll say, yes, we do. And it'll insert it. I then have two action methods, get settings again. Both of them, all they do is report back on the settings themselves. Let's come up here and let's run this now. And I'm going to remove all of these here. We don't need those anymore, but come down here to the settings. So we have the get settings. Let's try this one out and let's execute. Now I want you to notice the time. It's 08:39:52, and then some change there on milliseconds. But that's the time and date that this particular instance of that AdventureWorks API defaults class was created. If we now go down and we click on this one where we run this again, we execute this, look at this one. See, now the date time has increased by 1 second because it's about a second later or so that I actually did this. 08:40:19, right? So as the other one was 08:39:52. So it went from 39:52, it then went to 40:19. Now that's pretty cool. So this is showing you that a scoped version of this will actually get a different instance every time a new request is made. So that was the add scoped. What if we injected those settings as a singleton? And what we'll see is that the date time will be exactly the same because only a single instance of the settings class will be created. Now, before we do that, I'm going to go into this controller and I'm going to eliminate all those just kind of methods we did just to clean up our interface a little bit. So I'll get rid of those. Now let's go back to the program.cs, and instead of add scope, let's do add singleton. So by doing the add singleton, it's going to, the first time it's requested for injection, it creates the instance. After that, there's no other instances that will be created. So if we run this one now, so we click here, we try it out, we execute, look at the date time, okay, at least just the time portion, 08:42:41. So 08:42:41. If we try this one out, exactly the same, 08:42:41. So there's the difference between scoped and a singleton. Now, as I mentioned, normally we're going to use an interface with dependency injection. There are cases where we don't. So like I said, things that are very kind of singleton, more singleton type things where it's only going to be one thing like configuration settings, a database context, we can use just the name. We don't need an interface. But what's nice about using an interface is it does allow us to switch the implementation that we pass to classes. So let's say we have one service, a concrete implementation that gets data from a hard-coded class, but we have a different service, a different class that gets data from a database, and then a different service or a class that gets data from an XML file. If we use an interface and we inject using that interface, the controller doesn't know which of the above services is passed to it, and nor does it care. All it cares about is that it gets its data that it needs to do its job. And that's the whole reason why we use interfaces anyway, right? Whether we're doing dependency injection or not. Let's take a look at using interfaces with dependency injection. Right mouse click on your project and let's add a new folder called Interfaces. Let's right mouse click and add a new class called iRepository. Now I'm just using the class template here, but really I'm going to switch this to an interface. Interface, iRepository, it's a generic, so we can pass in anything, a product, a customer, an employee. And we have two methods, list of T, which is called get, and T as a nullable type, get with an int ID. Now, what does that look like? Yeah, you're right. It looks exactly like the repository layer that we created right here. So let's do this. Let's do a using on our AdventureWorks API.interfaces. Let's then implement this interface here. And we know that it uses products. There we go. We've now got this matching. So if we compile, we should see everything still works, right? Because we have the get, list of T, and we have a get with a product, and that matches now the interface. So how do we use this? Well, we go back to program.cs again, and we register it. So right here, we're now going to do a builder.services.addScoped, iRepository product, comma, and then our concrete implementation, which in this case is our hard-coded one. So product and then product repository. So now let's open up our product controller. Let's create a private read-only iRepository, and then we're going to create the constructor now into which it will be injected. So notice I'm using the interface, right? So then we don't care what that concrete implementation is. If we want to change that concrete implementation, we only have to change the program.cs. That's great. So now how do we use this underscore repo here? Well, if we come down here where we were creating the instance of that, we now can simply use that because it's the same thing, isn't it? Except dependency injection is taking care of creating the instance for us. Same thing down here, instead of the new product repository. See, so this is a hard-coded thing here. We've tied it exactly to a single class called product repository. When we swap this out for the interface, now we don't care what is passed to us. That product repository could be a different instance of it that goes and gets data from a database, which in fact is exactly what we're going to do later in this course. All right, let's try this out, make sure everything still works. It still should, of course. Go to our API product, we execute. There we go. It's getting all the data. Then we can come down and we can try out the other one just to, really make sure here. Try it out. We try our 706 value and we execute, and it goes out and it grabs our product. In this lesson, we learned that dependency injection inserts objects into our APIs, and it really is great for reducing those class dependencies because we're now going to typically use an interface. We can use scoped and singleton service lifetimes. They're the ones most often used. Typically, you want to definitely use interfaces, so I would highly recommend you do that. Coming up next, adding logging to our web API calls.